I think we can all agree that no one really wants their secrets to be out there in the internet. But I think only a very small amount of people is interested in your kindergarten secrets. And our next speaker really focuses on these kinds of secrets that can be turned into money, I would say. And also how to find them. So please welcome Mackenzie.
All right, thank you so much. It's a real privilege to be here. I've been to a lot of conferences, but I have to say the quality of all the talks leading up to this has been extraordinarily high, which makes me much more nervous than normal, but we'll give it our best shot. So just a little bit about me. I'm from Aotearoa, or New Zealand. I live in the Netherlands, and I work for a French company called GitGuardian. I just like to keep everyone guessing. You can find me anywhere on social media at the handle Advocate Mac, and I'm also the host of the Security Repo podcast. It's my mum's favorite podcast. She highly recommends it to all of you, so make sure you check. It'll make her very happy to check it out. Okay, so let's start off with what are secrets. I know everyone in the room probably knows this, but just in case, to get everyone to the same page, what I'm talking about when I'm referring to secrets are digital authentication credentials, and these are typically your API keys, security certificates, or anything that allows you to access different services or ingest decrypt data. They're basically the keys to the kingdom, and every attacker is after these because they provide a way of legitimately authorizing themselves into different services, which means that they can often go undetected. They're a great way to not only get initial access, but also to move laterally through systems and prolong their access and infect their way into different areas. So it's really important that we keep these protected, but as you'll see, these secrets actually end out sprawling everywhere. And you can find them in the weirdest of places, and attackers really rely on this. So what I want to do in this talk is go through a couple of different techniques that attackers use to discover these secrets, and I have some demos of exactly how they do this. So if you could all pray to the demo gods that everything works well, I'll appreciate that. But we'll talk a couple of ways. The first one we're going to talk about is finding secrets in source code. We'll talk about public source code and also accessing private source code. I want to talk about discovering secrets in containers. In this case, I'll use Docker images, finding secrets in mobile applications, and then at the end, we'll talk about how to prevent our secrets from leaking, which can basically just be summarized by don't hard code them, but I have a couple more slides. All right, let's go into the first part, abusing the GitHub API. So you're probably all familiar with this site. This is GitHub, the largest store of publicly available source code on the planet. What's interesting about GitHub is that for developers, it's not just a place to interact with open source code. It's a place for them to engage with the community. It's a place for them to show their portfolio. And it's a way for them to kind of work on their own code as well. And often you can have a kind of a private GitHub account that's assigned to your work, and then you have a public one. But you use the same account for both in most cases. Why this is interesting is that even if your organization has no exposure to GitHub, it will through its developers, which makes it a really interesting place to target, particularly because of the sheer amount of information that is there. So some stats that we kind of uncovered at GitGuardian. Last year, there was over 1 billion commits made publicly to public repositories. There was 85 million new repositories made in the public spaces, and about 94 million developers, according to GitHub, were using it. One of the things that we've been doing for about 6 years at GitGuardian is looking through all of this public information and trying to identify sensitive information there. So we actually scanned all of those billion commits last year to try and identify secrets. And we found a couple, which probably won't surprise anyone. But in total, we found 10 million secrets last year, just in public repositories on GitHub. And some people might question this and say, well, how do we know that they're real secrets? How do we know these aren't just high-entry strings or test keys? And the answer is that, no, we have individual detectors for each secret. We have about 400 individual detectors that we use. And in about 70% of the cases, we can validate the secrets with the provider. So not only find that, is this secret fit the format of an API key, but can we check with its provider and see that it's valid. So just a little bit of kind of what we found. 20% of the keys, so if you do some quick maths, 10 million, 20%, 2 million keys, were for cloud providers. And all of these we can validate. So 2 million valid cloud provider keys were pushed publicly in GitHub last year, which is a pretty extraordinary number. And we also find lots of interesting things, like the very last one, 3.8% is your version control platform keys. So basically, you've leaked your keys to your private code and your public code, which kind of makes the private code not that private. So how do we do this? As an attacker, how do we find keys on there? The first one I'm going to talk about very quickly, but it's not my favorite, and I'll explain why. But that's just using the GitHub search feature. It's called GitHub dorking. In this case, we're looking for a file name called credentials, good file name, AWS access key. You're going to get a lot of results from this. There's a bunch of dorks that you can do, but it's not that interesting. You will find valid keys, this method, but you're going to have to sift through a lot of information. And the key thing about Git is that in all version control systems, it persists to history. So if you do something on a development branch and you later remove it, it's still in the history. What the search feature does is it looks at the latest version and only the latest version. But where you'll find most of the secrets are buried in history of previous versions. So this doesn't get a whole lot of interesting information. But luckily, there's a much more interesting way to be able to discover secrets. And that's using the GitHub public API. So anyone can go to this address, api.github.com/events. You don't need any authentication, although you will be rate limited at some point. And that has a complete ledger of everything that's happening in public GitHub. And there's two events that we're specifically looking for. The public event, this is the most interesting, because this is when a private repository turns public, but with it comes all the history. And the other one is the push event, which is when you push code to a public repository. So we can quickly look at that. This here is the API. And as I said, anyone can go to this. But what's interesting is that when we're dealing with GitHub and the scale at GitHub, you're kind of protected by how much data there is. And as I said, there's 10 million API keys. And if you're looking for a specific API key for an organization, even if you just had all the valid keys, it would still take a lot. But what we can do is we can sort through the information that we have. For example, we can look at the email address of the authors of this, which again is all public. So here we have one interesting one I just saw looking down was for Yandex, which is, they call it Russian Google. And so if you were just looking to target this company, then you could just filter out the domains, and then once someone commits with that domain, you can look at their GitHub ID and then be interested in everything they do. So it's very easy to start filtering these results to actually get to something more interesting. So do adversaries actually use this as a method to gain access to keys? And the answer is yes, and I have a quick experiment that I would like to do very quickly. What I'm going to do is I'm going to create a honey token. So this here, you'll see, is an AWS key. It's actually a real AWS key, but before any of you get too excited and try and do any crypto mining with it, it won't provide any access. Instead, what this is like honeypot. It's a honey token, which if someone tries to use it, I'll be alerted. So I'm now going to commit a cardinal sin. I'm going to paste this into a file, a .env file, which should never be in a Git repository, and I'm going to make this public. And we're going to commit this publicly. So why would I do such a silly thing? I don't know if that worked, actually. Oh, yeah. So why would I do such a silly thing? I basically want to prove the point that attackers are monitoring this by continuing on with my talk. And as we get near the end, we'll come back and we'll see if anyone has tried to access this. So in here, crikey, that was quick. It's usually not that quick. I'll come back. It'll be more impressive later. So, is someone going to find that in that time? The answer is yes, someone already has, but some more people will too. And it's not, these aren't people refreshing the GitHub API. You know, these are bots that are scanning for that. This is an AWS key. It's a prefix key, which means it's easy to find. So it's the perfect key to try and run this experiment on. Okay. But there has been some breaches of this. This one's interesting, not because of how severe it was, but because of who was involved. So Toyota, car manufacturer, they were creating a mobile application called T-Connect. They built this application with a third-party contractor. That contractor, an employee for them, accidentally leaked some of this code in a personal public GitHub repository. Inside that code were hard-coded credentials to the database with a whole bunch of personal information of anyone that was using that, which is interesting for an attacker because I have personal information. I know that they have a Toyota, and I could craft some very specific campaigns to target them. So this is an interesting example. It sat there for 5 years before a security researcher found it and notified Toyota. But in that time, as we just saw, attackers are very quick, so there's no saying that an attacker didn't find this beforehand. And what's so interesting about this is that Toyota almost had nothing to do with this leak, apart from the fact that they had a contractor that had an employee that did it. And it just goes to show the kind of scale of which we can find keys like this at. Okay, so I have another little demo here, which is, what if you want to do the opposite? What if you wanted to see if your keys have actually ever leaked publicly in GitHub? And you can actually do that now pretty easily, thanks to a new little service. And so what I have is I have a file in here called secrets.txt. I wouldn't recommend that you create a file called secrets.txt, but for the demo purposes, this is it. And I have some keys in here. I have a GitLab key, an OpenAPI key, and a Stripe key. And what I wanted to do is I want to see if these have ever made their way into public GitHub. Now, we have a database at GitGuardian of over 6 years of all the secrets that have leaked on GitHub. So if you were to query that database, you could find out if your keys are leaked. And a lot of people might be squirming, thinking that I may suggest sending your plain text credentials to us to query, because if they weren't leaked before, they would be after that. But we're not going to do that. And what we're going to do is we're going to create a hash of our keys, which if we now look, we have a payload.txt file, and this just creates a hash of each line. So our keys are in here. And what we're going to do is we can send this to the GitGuardian database to query, which will send us back an encrypted file. And if we decrypt that, then we can find out if our secrets are leaked. So in this case, it's found 4 leaked secrets from that, and it tells us exactly where those secrets have leaked. So if you want to find out if your secrets have leaked, you can now do that with this service. And you do it by hashing it so that the secrets are actually never exposed. But it's a cool little thing that if you want to find out if you are, because in some cases, people like Toyota may not even realize that their secrets have actually leaked. So the service is called Has My Secret Leaked? We have a very fancy UI that's completely useless, but it gives you instructions on how to use the CLI, which is much more useful. I probably shouldn't have said that, but never mind. All right, now let's talk about accessing private source code. So public source code is really interesting because it's public. There's lots of information. I can show big numbers on the screen, like 10 million, and everyone's impressed. But private source code is really what you want to get access to when you're trying to exploit secrets. So private source code is really bad at staying private. There's been a huge amount of leaks from very big companies over the years. So last year, Microsoft, NVIDIA, Samsung all had large portions of their source code leaked. Twitch the year before had all of their source code leaked. And these are companies that I wouldn't consider to be amateurs in security, particularly not places like Microsoft. So why and how did these companies get their source code leaked? And the problem is that source code is distributed in so many different places. It's accessed by so many different people that the attack surface for it is really wide. You can target individuals, but you can also target misconfigurations. So this makes it really interesting. Now, a lot of people will say, yes, but source code shouldn't inherently be private or shouldn't inherently be sensitive. And whilst I would agree with that, the problem is what's inside that source code generally is when we're talking about secrets. And we find a huge amount of secrets in private source code that really surprises anyone when they actually have a look in there, particularly when we start looking in the history. So we have an example here. A typical company of about 400 developers that we look at GitGuardian will typically find on our initial scan 13,000 secrets in their private repositories. So that's just kind of based off some average on there. 1,000 of those secrets will be unique. So it's not 13,000 unique secrets. It's 1,000 unique secrets that have been duplicated, because that's what happens when they spread into systems. They sprawl everywhere. But unless you have a tool that can tell you that they're duplicates, you have to look at each one. So the same company may have 4 AppSec engineers, and then anyone here working AppSec will know that I'm probably being pretty generous with the 1:100 ratio. But imagine trying to deal with 13,000 incidents of secrets as a team of 4. It's completely impossible. So you do the next best thing, which is just ignore the problem and hope it goes away. But this is where we are in it. And attackers also know this. And if they can get access to the source code, get into the history, then they can uncover huge amounts of sensitive information. So we can look at one kind of case of this where source code has publicly leaked, and that's with Twitch. So they had their entire repositories, all of them leaked, from their core products to their secret tools that no one was meant to know about. There's about 3 million documents and 6,000 repositories. So this was uploaded, made publicly available, or as I like to say, involuntarily open sourced. And we scanned this for secrets, and we found 6,600 exposed secrets. That sounds like a large number, but actually that's way better than the standard of what we'd see. So props to Twitch for only having 6,000 secrets leaked out. But they still had 194 AWS keys, 14 GitHub OAuth tokens, so that would kind of persist access, and 4 Stripe keys, so payment systems. Now, in this case, the attacker did them a huge favor by making it public, because had they wanted to be more malicious, they could have not notified anyone about this and just sold those secrets or run more attacks. So that probably is the best case scenario if your source code gets leaked like this. But still, probably not a great week for the security team at Twitch. So how does private source code get accessed with these? So the Twitch case was a misconfiguration, and we can talk about that. One that's really popular at the moment is phishing. And you'll know that developers that work with developers know that they're really getting targeted more and more through phishing campaigns to try and access their repositories. And a friend of mine who works for a penetration test company called NetRegard knows this all too well. And pretty much in every penetration test he does, he tries to get access to GitHub repositories of developers. So how he did this was he bought the domain GitLhub, so it kind of looked close enough that people wouldn't be suspicious, and he created a complete mirror of GitHub. So anything that was happening on GitHub was also happening on GitLhub. So he then was targeting some people. He sent them out this email with GitLhub, and the next part of the story is you'd probably expect me to say that they clicked on it and then he had access to the source code. That didn't happen. They actually didn't click on it. They figured out that it was phishing, they reported it, and then the story kind of ends. But it doesn't. What ended up happening was Philippe kind of went on, tried to find other methods of attack for this appointment, and he forgot all about it. But he obviously kept GitLhub running because he might need that in the future. Then something weird happened. Someone on Twitter was sharing a repository but accidentally made a spelling mistake and shared GitLhub instead of GitHub. Now that wouldn't be too bad. It's not like this tweet went viral, but it did create something weird, which was that search engines now discovered GitLhub. And then you started seeing results for open source repositories that were from GitLhub instead of GitHub that were appearing before the original ones. And then Philippe, who was trying to target one developer, actually realized that he was targeting thousands of developers. He found out about this because he got a notification that his logs were full, and they were full of passwords for other people. Now, there's moments in every penetration tester's life where I'm sure they wonder which path they should go down. I'm sure this was one of them, and he decided to go down the good path here. But there's lots of other ways that source code, because this is just a kind of a fun example of, your source code can be accessed by lots of different people because it has so much access. But misconfigurations are another big one. When you go and initiate a new Git repository, you run the command git init, and then this folder here that's circled popped up, which is your .git directory. This is where all your metadata and history is stored. So when I talk about when you work on old branches and you're going back in the history, it's in this folder. It's kind of buried in here. But what often happens is this folder, which contains all your source code forever, becomes public. So Cyber News did a study. They did some wide-scale scanning, and they actually discovered that they found 2 million .git directories that were exposed to the public internet. So that's basically 2 million times where companies think that their source code is private, but is actually accessible if you just bother to take another couple of steps to look. And yes, this happens frequently as attack paths. There's better examples, but this one is just with an organization everyone knows, the United Nations. There was a hacking group called Secure Samurai. They did some domain enumeration just to find out lots of subdomains and check if there's any .git directories. They found one with hard-coded credentials for a database. And even more kind of scary, they found another subdomain that had a file called .git credentials in it, which I can understand if you accidentally expose a .git directory, not thinking it's sensitive, but .git credentials kind of has it in the name a little bit, which had access to their private source code. All right, so we can go do another little demo here of looking at how an attacker would go about this. So the first step that we need to do is to enumerate through our domains to try and find something interesting. So I'm just using Algolia as an example. They have a program that allows me to query this, and I know there's no vulnerabilities, so I don't want to expose any. But if we just run the tool subfinder with algolia.com, this will enumerate through all of its known domains. You can combine this with another cool tool called Chaos, which will find kind of additional domains for it. And what this will do is it will spit out a huge number of subdomains that belong to algolia.com. And why this is interesting is it's not that common that you will actually find an exposed .git directory on algolia.com. But test.algolia.com or repos.algolia.com is a much better example. And if you can find out all of those domains, then it gives you a great starting point. And the internet's a bit slow. I was really trying to talk as much as I can so that hopefully, well, there we are. Now we have it. So, a list of domains. And then the next step that we can do is just use another tool called Git Scanner. And we just input our domain here, and it's going to go through and check for us anything. So you'll see two results here. Not vulnerable, that means there's no .git directory there. Maybe vulnerable means that there is a .git directory there, but we don't have the permissions to access it. But often, if you take another step and try and access individual files, and you can often find that you can still access things and get into different areas. So worth further investigating on some of those, particularly if the domain's interesting. So this is just a quick example, really easy, of how you can find some source code that may not be private, and then recreate those repositories. And then from there, you obviously can scan for secrets and gain your access. So this is the process that I just used it. Chaos Subfinder, Git Scanner to find them and build them, and then I use a tool called GG Shield to scan them. So why is source code such a problem? Well, it's a problem for a couple of reasons, but the number one is, I've already talked about it, is about the history. And a lot of developers will say to you, oh God, come on, Mackenzie. I'm not going to leak my secrets. I'm not an idiot. But there's scenarios where that often happens. So here is one where a developer, this is an example of a Git tree. So if you're not familiar with software engineering, this may be a little bit foreign, but basically it's how we build software into the latest version. What we have there in the main branch is what the latest version of the software is. This is kind of, when you download something, when you visit it, this is the production version, let's say. But off that, if we need to create little features, we'll create what we call branches. So a developer in the team might work on a little branch, and I say, hey, I need you to connect to this database. And the first thing that they want to do is just check all their connections work. So they hard-code a key, not because they're going to leave it in there, they're not idiots. They're going to remove it, but they just want to check that it's all working. The next commit, maybe they remove it, add it as an environment variable or however else, and then they continue on. By the time code review comes down, that secret is 200 commits deep. The code reviewer just looks at the latest version with the latest version on the main branch, and that all gets merged, and no one actually knows that there's a secret that's persisted in the history. So this is why it's so interesting to look in the history of these things, because you can really see how the secret got ignored and how the developer that did it didn't actually know that they were making a mistake. Auto-generated files, so if debug logs get in your code repository, it often happens. Things like that can have environment variables, which are secrets. No .gitignore files, so that's a simple way to make sure that none of these sensitive files get accidentally into your Git repository, which combined with the secrets.txt example I had before, if you do git add all, that gets captured, and you can accidentally expose that. You can find keys in template files, like if you're creating a Django project, it will have the keys embedded in it. Now you have to remove those. It's not insecure how it does it, but you just have to know that you need to remove them. And then also we just see a lot of people sharing secrets on Git because they think that it's far more private than what it actually is. All right, let's move away from source code and get into some other interesting areas. So let's look at Docker images, finding secrets inside Docker images. I wasn't sure if I was going to do packages like on PyPy or Docker, but I decided Docker because there's some cool research that made it a little bit more interesting. But this is Docker Hub. So Docker Hub is the largest store of publicly available Docker images in the world. If you don't know what a Docker image is, then it's basically a mini virtual machine. Think of it as a way to package your application with an environment, with an operating system that it can run within. So, it means that you can not only send out your application, but send it out with an environment that it will work on. So that's what a Docker image is, really, really cool technology. And a lot of people choose to ship their applications in Docker images, and they store them on Docker Hub so people can pull them and use them. There's about 10 million public Docker images on Docker Hub now. There was some really cool research done recently by a German university, so props Germany, from RWTH University, which looked at what percentage of Docker images contained plain text secrets. And the answer was 8.5% of Docker images contained plain text secrets. This is absolutely wild. They went a little bit further and they told us how many secrets they actually found as well. So they scanned a total of 337,000 Docker images. We've also done research at this with GitGuardian, but this is far more extensive than what we have done, so it's a better case to point to. And they also found 52,000 private keys. One of the coolest parts about the research was that they actually created public keys from these private keys and matched them with known public keys. So they actually were, because they were able to prove that these private keys were actually sensitive, which I thought was really cool. So this just goes to show massive problem with identifying secrets inside Docker images. So the name of the study was Secrets Revealed in Container Images, an internet-wide study on occurrence and impact. These were the authors, just to give them credit on that study. So have secrets in Docker images been used by attackers? Yes, they have, regularly. The worst one was one from the CodeCov attack. This was a supply chain attack. So CodeCov was a code coverage tool, and it sat in your CI/CD pipeline. That may have sounded like mumble-jumble to some people, but basically, when you test your application, test that it's working, you do this in a CI/CD pipeline, generally, and what you want to do is you want to be able to test all of your application. CodeCov lets you know how much of your application is being tested, how much coverage you have in your tests. The point I make on that is it doesn't do something wildly sophisticated. It doesn't have access to huge amounts of things. It's just a good tool that did a simple job well. How you deployed this application was via the Docker image. But inside the Docker image, the publicly available Docker image, their main image was a hard-coded credential. This credential gave access to some source code, which was a bash uploader script. So when the Docker image was running, when CodeCov was running, it actually communicated externally with this script. And the keys that were leaked were read-write to this script. So they were able to modify the script and therefore modify the CodeCov application, and they turned it malicious. So what did this malicious code do? It was actually only one line. It was a very good line, though. And it said, every time CodeCov runs, I want you to dump all the environment variables, and I want you to send them to me, the attacker. So when you're testing your application, it does it in an environment. And that environment needs to have access to your database, to your third-party tools, to your infrastructure. Because if it doesn't have access to that, then it can't build the application and test it. So all of those secrets are actually in your environment. Now, some people say, yes, but we use test credentials for testing, not production. And that's great, and I hope that you do. But some secrets you can't avoid, like having secrets for your private code repositories. And that's what the attackers were after. So they were able to move from the public Docker image into the private code repositories of the people that were using CodeCov. So I was going to say it was a cool attack. It was an interesting attack. It sounds better. So one of the companies, there was a few companies, Rapid7, Monday.com, Twilio. None of these kind of did anything wrong. They were just caught up in a supply chain attack. So I'm not going to pick on them, apart from one of them. One of them I'll pick on, and that's HashiCorp. So HashiCorp is a pretty good company, and they create interesting products. One of them is a secrets manager. They invented the term secret sprawl, and they said that with our great product, developers will no longer need to have access to secrets. They'll never be in your repositories. You won't need to hard code them. We're going to solve your problem. And fairness to HashiCorp, it is a great product. But because the attackers got access to their private source code, HashiCorp had to announce that they had secrets in their private repositories. The point is, if HashiCorp has secrets in their repositories, there's no hope for anyone else. All right, so how do we discover secrets inside Docker images? I have another very simple demo here. First, I'll just show you this. One thing that you need to understand, this is what a Docker image looks like on the inside. It's built up in layers. This is a tool called Dive. I won't talk about it too much other than say what you see on the right is Python files. That's source code. There's source code in a Docker image. A lot of people think that this is black magic and that you can't extract anything, but there's source code in your files and you can pull that out. But you don't even actually need to, because you can scan a Docker image directly. I have one here. I'm using a tool, GGShield again, which is going to pull this Docker image, and then it's just going to scan it for any secrets in it. And I can pipe this. It'll take a few seconds, hopefully. And in this case, it's already found a bunch of secrets. These are all fake, but you'll get the idea from that. So very easy to uncover secrets inside Docker images. I'm running a little bit low on time, so I'll go quickly here. The last part that I want to talk about is finding secrets inside mobile applications. So what are mobile applications? When we look on our Play Store or our App Store, this is what we see. But what are these icons? So there's two types, but they're all non-human readable. And everyone knows that non-human readable means it's secure, right? That's how that works. It doesn't, because we can always get back to a human readable version from it. So if you're dealing with Apple applications, you have a .ipa file, and Android has a .apk file. And these are basically zip folders. Apple is slightly harder to get back to the original source, but Android is very easy, and Apple by no means you can't do that. So very quickly, I have another little demo that I want to do here. And the first thing is that I have this file here, my APK, my Android app.apk. The first step I need to do is to get back to some source code that I can read. So using a tool called JDEX, I'll decompile that, and I'll get back to the source code so that I can then look through that and try and find any secrets. Now, the secrets happen in mobile applications for different reasons, but it's quite scary how often they are inside there. And we're now done. So now in my Android app folder, I can go back to my sources, and I can see all the source code, which will include interesting things like the Android manifest, which is often we will find a lot of secrets from them. So this is a very interesting file. If I then want to scan this, I can just use the same tool here, GGShield, run this, and then that will go through, enumerate through those files and let me know if there's any secrets. So very, very easy, about the level of a script kiddie or below, because that's what I am. This will take a little bit of time, but I'll go back to the slides in the interest of time. So the workflow for this, if you're interested, I download APKs via a tool called gplay, which imitates a phone, so you can download it. I use JDEX to decompile it, and then I scan for secrets with GGShield. So very easy to do this for anything. An example of this one's from a friend of mine, Jason Haddix. He explained this on my podcast. And this one involves an application for a bank. So Jason was doing a penetration test on this, and he looked in this bank, which was a tier 2 bank in the United States. So a very, very big organization. This bank had some features in their mobile application. One of them was that you could take a picture of a check, and then that check could be cleared. Those pictures, after he decompiled it and looked through the source code, he realized those pictures were being stored on the phone itself, but not encrypted. He then realized that they'll be sent to an Amazon Simple Storage bucket, or S3 bucket, and right next to the line of code that said send to this bucket, it was use this key to send to that bucket. So he decided to do that and access 10,000 plain images of checks that other people had deposited from their bank. So this is an example of, it's not just small companies that leak secrets. This is an example of a very big bank, and it's a big problem. And one of the reasons for this is because people often think that your phone's obviously a computer. If you have to do everything through your back end, it can feel inefficient. So if we just connect our app directly to the source, it's much better. But there's no way of doing that. It's not a good idea. It's not a good idea to do that because you have to hard code the secrets. So Cyber News actually did some research into how many mobile applications have secrets, and they discovered that 55%, nearly 56%, contained hard-coded secrets, plain text secrets in mobile applications. Now, not all secrets are created equally, right? So you could have different things in here, like Slack keys or things that may not seem that sensitive, but they can still be used by attackers in different ways. The most common secret they found was Google Storage bucket URLs. So around about 17,000 of these, which is in line with the example of connecting to some kind of storage system directly from your app. OK, so just quickly, we'll go right back. So this is the mobile application I scanned, and we have some secrets that have been exposed. And what I want to do is just show you a couple of these secrets. Now, this is a real application I downloaded from the Play Store. I've masked all the secrets, and I've hidden the name. So I'm not exposing anything, but this is a real example, and we'll have a look at what we found in here. There's quite a bit. So first is some high entropy strings, which could be interesting. It's got API key here, but I'm lazy, so I'm going to go straight to the keys that I know are valid. So we have some Google API keys that are valid here, a couple to choose from. We have a valid Slack webhook. Now, Slack webhooks and things like that are often used for catching crash logs or sending information somewhere about the app so that you can look through it. But there can be great places to try and send phishing campaigns because they appear to come from your internal system. So they can be interesting for attackers. With some more Google API keys, and this one's really interesting, some Google OAuth keys, which can be very sensitive, and some Facebook keys, which are also valid, and a few bit more. So that's a real example from the Play Store of what you can look. If you want to ask me about how to do this for iOS or for Apple apps, I can. It's a little bit more involved, but certainly possible. So how do we prevent hard-coded secrets? Well, number one is don't hard-code them, even to test. And we could pretty much finish on this, but apparently it's very hard not to do this. And to be honest, I've also done it, so I can't really complain too much. But this is the number one. If we stopped hard-coding secrets, this is how secrets end up basically in all of our end files. If we didn't do it from the source code, they won't be in the end artifacts. But using secrets managers, using the best ones or heaviest ones might not be good for you. For example, HashiCorp Vault, very great product, but quite heavy. And if you're a team of 4, then 3 of you are probably going to be trying to manage that on their own. So I wouldn't recommend that. But there are kind of SaaS versions of that can happen. Then the clouds also have secrets managers, which can be great at least taking to the next step. And the step that I wouldn't really recommend to anyone is that you can encrypt them and store them in Git. I only mention these because, look, if this is what it takes to get you from hard coding them, then let's start there. But I really wouldn't recommend it because it gives you a pretty sensitive file. Using automation. So I work for a company called GitGuardian. I'm wildly biased about anything that we say, but you should definitely use GitGuardian. But there's also lots of open source tools. So GG Shield is one from GitGuardian that I have, but you also have TruffleHog, GitLeaks, Yelp, Detect Secrets, some other ones as well. Basically, there's no excuse not to have some kind of secret detection in you. It's very easy to set it up. You can put them in your pipelines. You can create Git hooks. There's lots of ways to do it. So obviously, there's commercial tools, but there's lots of open source tools as well. And then finally, what can you do beyond just not hard coding them? Rotate them regularly. Limit the privileges on them, and whitelist your services. So rotating regularly is really important because it means that you actually know how to rotate them, and then when you have a leak, you will know what to do. Because most of the time when leaks happen, people have no idea what the keys are for. Are you going to break production if you turn it off, and how it got there. But if you have a process to rotate it, then you can do that. Limit the privileges, obviously. Don't create admin keys for everything. If you only need to read data, then make it read data. And then whitelist services so that only trusted services talk to each other. So that's it. Thanks very much for listening. I'll obviously be hanging around. Here's some more reading material if you want. We have a model on how to maturely manage secrets, or if you're interested in some of the research I presented, the one on the right is going to be the state of secrets rule. So thanks everyone for listening. I hope you enjoyed it.
Thank you so much. We will have room for questions after the event. For now, we will have a very short 10-minute bio break, and then we will conclude the day with the last 2 talks. So see you in 10 minutes.